a very specialized application. The camera has actually very little role to play in the success of a machine vision system. Now, today's camera technology has become so advanced and commoditized that most camera makers or most camera products that you would see in the market do a pretty good job. Now, if it's good enough for a human to look at the image and identify features or identify the results that you want to inspect, then it's likely good enough for the software. The camera really has not so much of an impact when it comes to success. There are other more important criteria like your lighting as well as the software, which is even more impactful or critical in ensuring the success of the system. So inaccuracies or errors in machine vision is really categorized into two different buckets: false positives and false negatives. So if you have a system that's actually identifying defects, so in other words, the system has to flag the detection of a defect, so it's identifying defects. So when it's a positive, it actually means it's identified that part as a defect. And when it's done falsely, so in other words, a false rejection, that's known as a false positive. On the other hand, when you say negative, so it's categorized that product as not a defect or an acceptable part. So now when that's done falsely, that means it's falsely accepting a defective part. As you can imagine, a false negative is a more dangerous kind of defect for you. So you always want to err on the side of caution to ensure that there are no false negatives on your inspection lines. However, sometimes due to an oversensitive machine vision, you may actually end up seeing a lot of false rejections or false positives. And the way to counter that is really by analyzing the kind of false positives you are seeing. Now, if it's an AI-based or a deep learning-based systems, a way to check this would be to ensure that the features, to analyze the features or to see whether it's belongs to a certain category. So it may be due to not enough training data, a balanced training set, that you have not trained the system adequately enough. But it's important for you to actually categorize those images and have a very disciplined process to analyze them, to inspect all those images manually, to be able to then define an intervention to counter these false positives. Oftentimes the mistakes that I see people make is they look at a very small subset of images and then try to engineer that based on the smaller subset. And this may solve the issue for the small subset, maybe because of the variant or because of a certain type of defect. But then you tend to ignore the other categories which you've not really engineered this for. So when you look at this analysis, make sure that you see it across the broad variants, across all your permutations and combinations, and then ensure that mitigations in terms of training are implemented so that you can arrest those false positives in an accurate way. So the main objective is to ensure that you're replacing your manpower, isn't it? But practically speaking, that's not going to happen overnight. So when you're implementing a machine vision system, you have to ensure that there's some adequate supervision of the system itself. Now, you're probably better off eliminating human resources in a phased manner. So if you have multiple lines and you have multiple teams inspecting this, you may want to replace or cut down on this in a phased manner to have, let's say, one person that's supervising all three lines. So, in other words, you could have some sample inspection that's happening after the inspection by the machine vision system, or you could be, you could be inspecting all the rejections to ensure that there are no false rejections. So, in that process, staggering reduction of the manpower is likely a better bet until you see full confidence in the system. But even then, you always want to make sure you have doing some level of monitoring to ensure that your vision system is always performing at its expected accuracies. You never want to let this go unmonitored because you never know when you're going to run into surprises. So the skill required to develop a machine vision system and to implement a machine vision system is actually very different. You don't need to be an expert in implementing a system, but you need to have sufficient expertise that when you've outsourced this or you're managing the project for a machine vision system, you have the expertise to evaluate and make sure that it ends up in a successful install. So what skills are really required to monitor and drive a project implementation? Well, the first one is you need to understand the basics of machine vision, because there are so many systems out there, from smart cameras to PC-based to AI-based systems to rule-based systems, and oftentimes I see that there's a lot of confusion around what the difference is between all of them. So you end up comparing, apples with oranges, a smart camera system with an AI-based system, and you end up, with the wrong choice, and you end up, not seeing success. So firstly, make sure you understand, what is being proposed by the different vendors or by the different technology providers for which you're evaluating these system vendors. So once you figure that out, the next thing is to ensure that, what is going to be the measure of success, right? So any system that comes in has to be monitored for a given sufficient amount of time to ensure that all your inspection criteria are sufficiently and accurately met. So it may be due to practical considerations, not all of your SKUs are being planned for production. So make sure you have a project chart that communicates to the vendor or communicates to the project team that you would like to see at least a certain percentage or certain number of these different SKUs go through your inspection system and correctly classify these for defects. And that may happen over a larger period of time. Now, if your SKUs or if your defect inspection parameters are very similar, then you may choose to actually do this for a subset of SKUs or variants, and assume that with that the qualification will be sufficient to predictably handle the future SKUs that are going to be run in your line. So the third skill is really ensuring that you are able to manage a vision system in terms of changes to your production plans. So it could be addition of variants, it could be removal of variants, it could be changing maybe the sensitivity of a defect, or it could just be generating a report and then being able to analyze it for root causes. So you need to have enough skills to be able to monitor as well as make these changes to the system so that you're not dependent on a vendor or third party. That way you'll be in full control and ensure that you're maximizing the use of your vision system successfully.